Good afternoon, evening, morning, everyone. Hope you're having another beautiful, fantastic day. Today we're going to be talking about higher order derivatives. Higher order derivatives just mean doing a derivative of a higher order polynomial. For example, you can do a second derivative, or a third derivative, or a fourth derivative, and all that means is taking the derivative of a derivative multiple times. So let's figure out what this is going to look like here. Example 1 says find the first and all higher derivatives of, and it gives us a function p of x here. So let's work this out. First off, I want to find p prime of x, the first derivative. Now your first derivative is going to be just a regular derivative, so drop your 4 down, so we have negative 8x to the third. 3 times 9, so we have a plus 27x squared minus 2 times 5, so minus 10x, and plus 7 just goes away, right? Now we can take another derivative of that, and the derivative of that is going to look like this, p double prime of x. We call this the second derivative. And all we do with that is take the derivative of the derivative. So take the derivative of this guy. 3 times 8 is going to be negative 24 x squared plus 27x squared. So take the derivative here, drop down your 2. 27 times 2 is 54x minus 10. Then we can take the third derivative, which is 3 apostrophes there, 3 little ticks at the top. The third derivative, drop your 2 down, this is going to be a negative 48x plus 54. And you have a fourth derivative. Now usually when you get to the fourth derivative, we just write p and a 4 up here, kind of like that. Let me zoom in there so you can see what that looks like. p4 of x means the fourth derivative, which is negative 48. And then p to the 5 of x is 0. So let me give you a little bit of vocabulary here. Pull this back a little bit. Okay, the number of times that you can take a derivative before you hit 0 is called the differentiability of the function. So what we would say is that since we have a possibility of up to 5 derivatives here, we would say that p of x is 5 times differentiable. Means I can take the derivative 5 times. P of x is 5 times differentiable. Now this is going to come in handy because you are going to start seeing questions that say a function, p of x, is twice differentiable. That doesn't mean that they give you the second derivative, but it means that you can find the second derivative. Okay? So for example 2, it says find the second derivative of 4 cosine x plus sine x. There's no chains here. There's no products. The only thing we have is just regular trig functions. So f prime of x for the derivative of cosine is negative sine. So 4 times negative sine x. And then plus the derivative of sine is cosine x. So we can say that that's going to be negative 4 sine x plus cosine x, right? That's f prime. So f double prime of x, your negative 4 is still here, so it's negative 4. The derivative of sine x is cosine x, plus the derivative of cosine is negative sine x. And that's it. Now I would simplify this one more step. Say this is negative 4 cosine x minus sine x. All right. So that's 2 derivatives, a second derivative there. So not that weird of a concept. And what we're going to learn about later on as we go are the relationships between these derivatives and what they mean. We're going to learn a little bit about that today, and then we'll really delve into it tomorrow. The good news is if you had physics before, you probably already know what we're going to talk about today. So let's look at example 3. Now example 3 gives us a graph, and it says find the first and second derivative of that graph. Now first I'm going to need to know what the graph is. Okay, so this is a sine wave. I know it's a sine wave because it goes through 0, 0. If it was a maximum or minimum on this part, then it would be a cosine wave at 0. Where x is 0, if you had a max or min, it'd be a cosine wave. And if it was that weird dancing thing with a tangent line and an asymptote, it would be a tangent line. So this is a sine wave. Now this is something you have not seen before, unless you saw it in physics. For a sine wave, it's y equals a sine bx. Now a is the amplitude, and that is the distance. Let me draw a little wave here. That is the distance from the middle of the wave to the crest or to the trough of a wave. That's your amplitude. And then B is your period. And period is how often one wave repeats. So a period is this distance from here to here. How often one wave repeats itself. And the period is always 2 pi divided by b. One period is 2 pi for sine. It completes one sine wave in the length of 2 pi, like your unit circle is, 2 pi. So the period for this is going to be 2 pi b. So to come up with the equation for this guy, what I'm going to do is look at the amplitude, and I'm going to look at the period. Okay, so for the amplitude first, here's 1, here's 2, right? So this has an amplitude of 1. So what I'm going to say here is that it's going to be y equals 1 times the sine. And we've got to figure out what your period is. Now the period here, in this case, it's supposed to be 2 pi. So what I'm going to do is how many times does this wave repeat itself within that 2 pi time frame? Here's what I'm talking about. Here's 1 pi, right? Here's 2 pi. So you're looking at how long does it take before this thing actually goes through and completes one wavelength. All right, now remember this. 1, 2, 3, right? So 1, 2, 3, 0.14. There's 3.14. Then 4, 5, 6. Here's 2 pi. So how many waves did you complete in that 2 pi length? In that 2 pi length, we completed 1, 2 full waves. All right? So our period here, in other words, is going to be 2. 2 pi over b. So out of 2 pi, taking and dividing out that pi level then, how long did it take to go one length? It went pi. So here's how we use this formula for period. Your b is how long it takes you to do one length. Now you could do it the way I did it at first and just say, oh, it's 2 pi because that's, or it's going to be 2 because that's how many are completed in 2 pi. If you want to see the actual formula working for you, you got the period is 2 pi over b. B is how long it takes to do one wave from here to here. Well, that took pi. So your period is 2 pi over pi, which is 2x. So the equation for this line is y equals the sine of 2x. And they want us to find the first and second derivative. Well, this is going to involve a chain because you've got a 2x in here, right? You've got a nut inside of this thing. So it's going to be, you've got your outside, you've got your inside. The outside is sine, the inside is 2x. The derivative of sine is cosine and 2. So it's going to be cosine of 2x times 2, which is 2 cosine 2x. That's the first derivative. Second derivative, we've got our outside here, O and I. The outside is going to be 2 cosine. The inside is 2x again. So the derivative of 2 cosine is going to be 2 times negative sine, and then times 2. So this whole thing is going to simplify to 2. Let's go ahead and make it a negative 2 when these multiply out here. Negative 2 sine of 2x times 2, which is going to be negative 4 sine 2x. There is the first and second derivative of that function. So let me backtrack just for a second here, because I know some may not have seen this trig value before. Again, A is your amplitude, B is your period. Your amplitude goes from the middle to the top of a crest. In this case, it's 1. Your period, you count how long it takes to do one wavelength, and you plug that in for B right here. So you take one wavelength and plug it in for B. In this case, one wavelength was pi. So we put that in. 2 pi over pi is 2. All right? Now, this is where things are going to get a little cross-training with physics, because now you're going to be introduced to the idea of position. So let's say that S of t is the position function of an object, right? Let's say that S of t is its position. Well, the rate of change of the position with respect to time is velocity. What is the deal with rate of change again? Rate of change is the derivative. The derivative of position is velocity. The rate of change of velocity with respect to time is acceleration. What does that mean? That means that acceleration, A of t, is the derivative of velocity and the second derivative of position. Okay? So it goes like this. You start with position, S of t. If you take the derivative, S prime of t, you get velocity. If you take the second derivative of position, which is v prime, you get acceleration. So position gives you velocity, which gives you acceleration. Okay? Now, I wish that we would be able to teach this first before we go into physics, because this makes physics so easy. So easy. Example 4, assume that a moving object along a line is given by this function, and somewhere between time is 0 to 8, right? Letter A says, find the beginning position. The beginning position. Well, that happens when time is 0, when you start. When time is 0, that's when you began. So I want to find S of 0. Plug a 0 in there. So you got 3 times 0 cubed minus 40.5 times 0 squared plus 162 times 0. That was easy. It's all 0.